Hey there, future electrical engineers. Ever wonder how your phone works? Or what makes your TV light up? It's all thanks to the magic of electronics. Electronics is the study of how to control tiny particles called electrons. These little guys are responsible for powering everything from your toys to spaceships. Don't worry, you don't need to be a rocket scientist to understand the basics. In this essay, we'll explore the fundamental concepts of electronics: voltage, current, resistance, and power. Get ready for an electrifying journey. Everything around us is made up of tiny particles called atoms. Atoms have even tinier particles called electrons. Think of electrons like tiny balls of energy that are constantly moving. Electricity is simply the flow of these electrons from one atom to another. Imagine a long line of people passing a ball. That's kind of like how electrons move through a wire, creating electricity. This flow of electrons allows us to power all sorts of amazing things. Now, what makes these electrons move in the first place? That's where voltage comes in. Voltage is like the pressure that pushes electrons through a circuit. Think of a water hose. The higher the water pressure, the faster the water flows out, right? Voltage works the same way. A higher voltage means a stronger push, which makes more electrons flow. Voltage is measured in volts. A regular AA battery has a voltage of 1.5 volts, while a wall outlet has a much higher voltage of around 120 volts. We've got our electrons moving thanks to voltage, but how do we measure how many are flowing? That's where current comes in. Current is the flow of electrons through a circuit. Think of a river. The wider the river, the more water flows through it, right? Current is similar. A larger current means more electrons are flowing. Current is measured in amperes or amps. A small light bulb might only use a few milliamperes, while a large appliance like an oven might use several amps. Section 5. Resistance controlling the flow. Imagine trying to drink a milkshake through a very thin straw. It's tough, right? That's because the narrow straw creates resistance to the flow of the milkshake. Resistance works the same way in electronics. It's the opposition to the flow of electrical current. Materials like copper wire have low resistance, so electrons can flow easily. Other materials, like rubber, have very high resistance, which is why they are used as insulators. Resistance is measured in ohms. By adding resistors to a circuit, we can control how much current flows through different parts of the circuit. Section 6. Power, the energy we use. Power is the rate at which electrical energy is used. Think of a light bulb. A brighter light bulb uses more energy than a dimmer one, right? That means it has a higher power rating. Power is measured in watts. A 100-watt light bulb uses more energy per second than a 60-watt light bulb. Understanding power is important for choosing the right components for our circuits and for calculating how much electricity we use. Section 7, putting it all together, how these concepts work together. So we've learned about voltage, current, resistance, and power, but how do they all fit together? Think of it like this. Voltage is the pressure that pushes electrons. Current is the flow of electrons. Resistance is the opposition to the flow. Power is the rate at which energy is used. These four concepts are related by a famous law called Ohm's law. Ohm's law states that the current flowing through a conductor is directly proportional to the voltage across it and inversely proportional to the resistance. In simpler terms, this means that increasing the voltage increases the current and increasing the resistance decreases the current. Section 8. Real-world examples. Electronics in action. Now that we understand the basics, let's see how these concepts apply to real-world electronics. When you turn on a light switch, you are completing a circuit. Voltage from the outlet pushes electrons through the wires and the filament of the light bulb. The resistance of the filament causes it to heat up and glow, producing light. Your smartphone is packed with tiny electronic components that use voltage, current, resistance, and power. The battery provides the voltage, while the circuits control the flow of current to power the screen, processor, and other components. Electric cars use a battery to store electrical energy. When you press the accelerator, the battery provides a high voltage to an electric motor, which converts electrical energy into mechanical energy to turn the wheels. These are just a few examples of how electronics shape our world. Section 9. Conclusion. Keep exploring the exciting world of electronics. Congratulations! You've taken your first steps into the fascinating world of electronics. We've learned about voltage, current, resistance, and power, and how these concepts work together to power everything around us. But this is just the beginning. There's so much more to explore in the world of electronics. From building simple circuits to designing complex robots, the possibilities are endless. So keep experimenting, keep learning, and keep that spark of curiosity alive. Don't forget to subscribe to our channel for more exciting content and updates. See you in the next video.